an escape from the dark ages of programming. Programmers have been trying to visualize their programs, their internal microarchitecture, for ages. Only two things have really worked, and both are very primitive. First is the actual directory layout where the program files are kept. It is a primitive way of categorizing things, sometimes concepts like input forms or user interface themes, other times more generic concepts like plugins, where plugins can hook into all kinds of other things. The second is the most obvious thing, the documentation. But it really takes forever. It needs updates when the code changes, and it better have examples, diagrams, and maybe even an occasional tutorial. Great for a group of programmers, maybe, but insane to attempt for just one. There's a slight shortcut here, as sometimes text for documentation can be pulled out of well-structured code comments. This is sometimes driven by static code analysis tools. Here, code is parsed by a computer, but rather than being executed, it is queried for the purpose of generating a lot of the documentation. But now, the lone programmer needs to comment all the code, or at least try to, which is yet again another way of writing documentation, though not as detached from code and only a bit at a time this time. I once ran an experiment where I embedded instruction to create visual code graphs using GraphWiz. I embedded the instructions directly into comments. It worked. A large, high-level graph of concepts within the program emerged, and multiple concepts can be stored in code at the same time. It was just whatever you put in there is what you get out. Problem here is, the moment you see a pretty graph of your program, you want it, nay, you need it to be interactive. This is where visual programming comes in, as demonstrated by geometry nodes in Blender and Node-RED. This works, it really works, but there is a flaw. To program with just the visual nodes, a visual programming language is required. The language has to be made out of visual nodes. Here we hoist things like if statements or loops into the graph, the visualization itself. Unfortunately, the result is a tangled graph mess because we just hoist too much low-level concepts, ifs and each and filter and map. It's a mess. To contain the mess, we make a bigger mess by adding a third dimension to our two-dimensional graph and grouping nodes to create custom nodes that then don't need to show all their internals. Here the custom nodes will hide all the each and if and filter statements, but the program structure here becomes really rigid. There's no refactoring here. The only way to address the code is to quit and retire as a programmer. There once was a promising attempt to visualize object-oriented programming, but again, here we hoist objects, methods, and properties into the visualization. And on top of that, object-oriented programming is just a tool. It shouldn't attempt to contain entire applications. Not everything should be an object, and in fact, in real world, not everything is an object. Another promising attempt was Apple Automator. Here, you don't branch at all. There is no confusion if you're not branching. You simply arrange a column of high-level actions, such as resize image, upload file, and frankly, that's it. There may be an unexplored area here, where allowing the creation of custom high-level actions may make creation of applications possibly reasonable and make the code somewhat readable, but I am not sure. But if all we are dealing here is a list of actions, then we can just do it in code. Just create a list of high-level functions and hide all the logic beneath. It is possible to create an automator in code or even in a text file, and that pretty much means the UI that automator presents is not that helpful. I mean, it is helpful for a novice user that's trying to program something, but it is not helpful for what we are trying to do here, to document code, to make the internal microarchitecture of a program more readable. We can just do it in text. Everything that has been tried, everything showing promise, has basically failed to impress. It failed to deliver. It was maybe read-only, or the editing was too annoying when compared to just typing code in. Either high-level concepts were blurred or buried, or just didn't go far enough to make the system useful. I suspect there is one more thing left to try. And here we borrowed the user interface from content management systems that have concepts like article or menu and menu item or post and blog or even image, and create a high-level code management system with concepts like button or input form or dashboard, list specific events that occur within the application that are now easy to find because they are in a GUI. There's one big problem here, because this system requires that a new code management application is written for every application that's being edited. And a pretty huge issue, but it is fixable. Here, introducing generic concepts such as plugins or modules is a huge mistake. We can't say, click a button to add new plugin module. This will only create a mess where the programmer will now have to consider what is this plugin module doing. We need to be more specific. What needs to be done, and this may perhaps be shocking, is the UI for the code management system not only has to be written around the application, but for all the things within it. Each programming project will have a pretty but unique user interface aimed at the concepts within the application. Do not be reusable or generic. Do not speak in terms of components or objects. Be specific. Name things for what they are. As a result, we create a concept map of the application with the user interface itself. I will close with an example and try to keep it simple, though it will sound awful. An example of a code management system for the creation of Bootstrap themes. They are just GUI decorations for web applications. This is a deceptively complex challenge. For those of you who are still sad that I said bad things about OOP, you can see here that UML, or Universal Modeling Language, and OOP in general won't work. Visual programming may actually have performance issues for all the nodes that would have to be on the screen to get a complex theme out the door. But a code management system, or something based on a content management system that operates around concepts specific to theme development, well, at least in theory, would keep everything in check and ordered and easy to navigate and easy to recognize and even remember. Let us make a simplistic dashboard with some interesting cards inside. We click New Project, add a page, call it Dashboard 4, a side pane showing all the existing components in the system would show on the side, and then dragging the dashboard component into the design area in the center of the screen would create a UI to configure the dashboard. So we're not dragging a dashboard, but a control applet that helps us configure it. This is not a generic container, but an administrative component specifically crafted for creating dashboards. We point to a data source or a code function that creates some test data for the cards, and now point to a card component that we will be using in this particular dashboard. Clicking Save and Build will create a new sample dashboard in the theme project, which we can now go back and customize further. The reason why this kind of thing could work is because there is another part of the program here that isn't visible in this example. A new dashboard container can be created in a slightly more complex user interface that can be pulled up by some menu somewhere. Or an existing dashboard container can be edited. And same goes for cards, menus, alert boxes, the full range of components that goes along with a theme. A simple context menu, or Clippy even, would allow jumping between the different parts of the application. So there are low-level things, medium-level things, and high-level things like the dashboard creation. A code management system is crafted for a specific purpose. It must not deal with generic concepts. Rather than adding a new UI container, which would make the programmer wonder, what is this container actually containing? We have to use specific high-level concepts. Dashboard, or maxi dashboard, or mobile dashboard, or card group, or even card group, or newspaper layout card group, or input form, or password form, or profile form. Here, the application itself serves as a diagram of the system, of the theme that we are creating. The buttons and UI are a kind of self-documentation. When time comes to update some dashboard code down the road, you look under Components, Dashboards, click the Edit Code button, and get a code mirror code editor to edit the code. So the convention here is to use very high-level concepts, very specific concepts, because it is easy to navigate all the complex ideas where everything is spelled out for you. The user interface then becomes a concept map. And I think it is pretty safe to say it would be easy to return to a particular Bootstrap theme or any other application and figure out where everything is at when the menu on your left-hand side is spelling out all the components of the system. Remember, this is a code editor where we replace the concept of documentation or even folder structure with an informative user interface. So it looks like a builder of bootstrap themes, but it is actually a visual programming environment done correctly. The UI is mapping important concepts. It is not a UI made specifically for making bootstrap theme editing easier. No, it is a concept map for a programmer made with graphic user interface components to help them navigate complex microarchitectures such as some part of a theme or some part of a database or some part of a smartphone app. Code management systems are not for making things user-friendly, but exposing the internal architecture of complex projects as user interface.